Black math! Give me some math and I'll give you some flack. Black math!
We're talking about traps and kites.
Isn't it a like four-sided figure?
So it's a quadrilateral with at least
One off two singles.
two parallel sides, right? So it's got one pair, at least one pair of parallel sides. Now, technically, depending on what math curriculum you're looking at, a trapezoid, a parallelogram is a type of trapezoid. Because the definition of a trapezoid in some textbooks is at least one pair of parallel sides.
What is it in our text?
So like a rectangle would be a trapezoid in that textbook. Does that sit right with you? I don't like it. So I don't know what depending on who you talk to, whatever. But the bases of a trapezoid are the two parallel sides. So this is a base. So you could call this base 1, base 2, or you could call this base 1 and this base 2. It doesn't matter which one's longer or whatever. Yes.
What lesson is this?
This is lesson 69, and we're going to do 69 and 70 today. And so the practice test, remember, if you do your practice test by Thursday, 5 points. So bring it with you on Thursday because we're going to go over it. So do it by Thursday, okay?
Ben, I do it most of the time.
You do. You're like sometimes the only one who does it. Yes.
How many tests do we have until the end of the school year?
Probably 4.
That feels like a
So
dramatic
like
amount.
one every 2. Never mind, I'm not thinking straight. Like one every
Oh my gosh. Sorry.
3 weeks.
6 weeks. 3 weeks.
3 weeks. One every 3 weeks. That feels like a dramatic amount of tests. I don't know. Does the final count?
Wait. How many more days until the 18th? Wait, what? Just kidding.
What?
To the 19th?
So it's 17 days. It's the second. Oh.
Okay,
No,
this is fun math. So let's do
16.
this math. Okay, so basically you got bases and legs in a trapezoid. The bases are the parallel sides. The legs are the non-parallel sides. Are you guys okay with that?
It's just maybe.
All right. So it kind of makes sense, but sometimes you got a weird looking trapezoid. Like maybe here's a trapezoid. So these are still just the legs. And this is the base. So it's not the which ones are longer or which ones are shorter, nothing like that. The bases are the parallel sides and the legs are the non-parallel sides.
What was it? 69.
Are you saying my legs aren't parallel?
I don't.
So what's
my,
that?
One of my legs
Are
is
you saying
longer
my
than the
legs
other.
aren't parallel?
For the parents.
I can't make one of my legs magically longer.
Yeah.
Oh. Like that was just an adjustment.
So,
No, one of my legs is longer than the other. I'm not a symmetrical.
so what do you think the mid segment of a trapezoid is?
Oh, it's a point. It's the midpoint. I don't know.
Do you remember what the mid segment of a triangle was?
The point like from the middle that like all this distance are equal to. Yeah.
Not the centroid. So the mid segment of a triangle was something like this, where the midpoint of that side, the midpoint of that side,
Yeah.
and it ended up being parallel to the base of the triangle.
That
So-
would be the case here, wouldn't it?
Yeah, so you find the midpoint of this leg, midpoint of this leg, and that is the mid segment. Okay, so here's the definition of a mid segment. Endpoints are the midpoints of the legs. Okay, this is a segment whose endpoints are the midpoints of the trap's legs. Okay, does that make sense? So just connect the two midpoints and guess what the first theorem is going to be?
Don't we already know about mid-segment?
We do in a triangle. Good question.
Oh, right.
I like to feel like
Right.
Okay, guess what that first theorem is going to be?
theorem 27.3. I don't know.
Any guesses?
Wait, what?
So all we know is the definition of a mid-segment. It connects the two midpoints. What can you tell me about that mid-segment? Yes.
That the mixed segment is going to be parallel to the base.
Yep, to both bases.
Wow.
Yep, so
Parallel.
So here is theorem 69-1, which says trapezoid mid-segment theorem is the mid-segment of trapezoid is parallel to both bases. Okay, and here's something else. So mid-segment is parallel to both bases. Anything else that you can tell me about the mid-segment? Yeah.
The length of it is the average of the two bases.
Yes. Good job. So that length is half the sum of the bases. So remember, this is actually how you find the area of a trapezoid. It's the average of the bases times the height. Or now we can say the area of a trapezoid is the mid-segment times the height, and you're done. Okay? So parallel to both bases and half the sum of the bases. So basically it's the average. It's halfway between the two bases. So if this was like 8 and this was 12, then your mid-segment would be what?
4.
Halfway between, right? Or add them up. 8 plus 12 is 20. Divide by 2 is 10. Okay? Again, your gut already told you this. You just look at this and you're like, oh, that makes sense. I can probably figure that out. If I forgot all these theorems, I'm going to use my gut because I trust my gut. Okay? And so there's some examples. I mean, this is going to waste your time, so I apologize for this. But let's say this is a trapezoid. We got A, B, C, D. And then here's E, F is the mid-segment. So what is the length of the mid-segment? Raise your hand if you know it. Don't say it out loud.
Which one?
What's the length of the mid-segment? So EF equals... Tristan?
That's it. 20.
20, yes. You guessed it. Okay, so you could use your gut, or it's just the average. So 15 plus 25 is 40, divided by 2 is 20. You got it?
Yeah.
Good? All right. So there's another kind of trapezoid, which is the trapezoid that you guys probably think of when you think of a trapezoid. It's called an isosceles trapezoid. Any guesses on how to define an isosceles trapezoid?
I have an idea.
In some textbooks, a square would be an isosceles trapezoid. What's your idea?
The top would be half the bottom.
Okay, good guess, but no.
Also, you missed a page.
Okay, any other guesses on what an isosceles trapezoid is?
I think isosceles triangle.
Good question. Isosceles triangle has 2 sides of the same length.
That's
Is it?
It's one that has 2 sides of this trapezoid with 2 sides of the same length.
Okay, yes. So those 2 sides
Oh, but they don't have to be
have to
parallel.
be the legs. That's
Yeah,
right.
'cause they don't have to be parallel.
Yeah, because if the 2 parallel sides had the same length, then what would that be? That would be either a square, a rectangle, or parallelogram. Okay? Okay, so an isosceles trapezoid is a trapezoid where the 2 legs have the same length. Okay? So here's an isosceles trapezoid. This is what it looks like. Okay? So in order to know for sure that this is an isosceles trapezoid, I'd have to designate that those are parallel. So the 2 bases are parallel. The 2 legs are the same length. So you're good. Yes.
Can I go get my water bottle?
Yes. 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 Okay. So here is the deal. What else can you tell me about this Trapezoid, A, B, C, D.
Oh,
You said first. What do you think?
A and C would be complementary.
No.
Angle C.
A and C would not be complementary. Tori?
it's what is it? Isosceles trapezoid because
It is. Yeah. What else can you tell me? You were on the right track, Tobin.
Would it be A and B?
A and D and A and C are supplementary.
Oh.
But basically what I'm trying to get to is that these angles are the same. So if the legs are the same, then those angles are the same. Now there's a special name for those angles. We call them base angles. So these guys are the base angles. Base angles in an isotrap are congruent. So this is theorem. No, it's not a theorem. It's just properties. Property of an isosceles trapezoid. So not only are these the base angles, these are the base angles as well. So D and C are going to be congruent, and A and B are going to be congruent. Okay. So there's no rule that says you have to put draw the trapezoid with the shorter side on top. Okay. This is still an isotrap. Right? These base angles are the same. These base angles are the same. Okay, so far so good? Does this feel all right? So if those are the same, that means, and since these guys are parallel, remember, this is a transversal of two parallel lines. Two same side interior angles are always supplementary. They have to add up to 180. So if you put this angle right down here, it would form a straight angle. Okay? So these are supplementary. So here's what the property says. Base angles of an isotrap are congruent if trapezoid. Okay. So far so good?
Yeah.
All right. There are some examples. You just have to find the measure. So for example, if this is 107 degrees, then what's the measure of all three other angles? Do you know?
73, 107, and 73.
Yep. Does that feel all right? Okay, so these are going to be supplementary. Again, go with your gut. Those have to add up to 180. These are the same because it's an isosceles trapezoid. All right, now moving on to kites. Well, actually, one more about a property of an isotrap. The diagonals are congruent. So we can say diagonals of an isotrap are congruent. So BD equals AC. Okay, again, your gut would tell you that. They look the same, so they probably are. Okay, good? So I think we've exhausted all the different cool things about an isotrap, so let's move on to something else. Okay, so this is a kite. A kite is a quadrilateral that has two pairs of congruent consecutive sides. So not opposite sides, two pairs of congruent opposite sides, that's a parallelogram. Okay? But a kite has two pairs of consecutive congruent sides. Okay? All right, so the diagonals of a kite. Here's property number one. The diagonals of a kite are what? What can we say about the diagonals of a kite?
I forgot the name. Perpendicular.
Perpendicular, good job. So diagonals of a kite are perpendicular. Okay? And again, they look perpendicular. They look like they form 90-degree angle. Okay? So I'm going to do something a little crazy here. I want to find so technically what I could do is I could find like the perimeter of this kite. How can I find the perimeter of this kite? How on earth can I find the perimeter of this kite? Tobin?
A bunch of triangles. Can't you just find the hypotenuse of all?
Yep, because they're all right triangles. And we know that because the diagonals are perpendicular. So this is 5. This is 5. This is going to be, let's see, square root of 116, which is probably something. So now that I have all the sides, I can add them up and find the perimeter. Okay? So just some little things that you know, because you know that the diagonals are perpendicular, that opens up new worlds. All right, that's trapezoids and kites. You guys feel pretty good about trapezoids and kites?
Yep.
Okay. Moving on. Okay, this is stuff you already know. Let's surface area of prisms and just pyramids. Surface area and volume of pyramids. Okay, so for example, here's a pyramid. Okay, so the surface area is just the bottom and like 4 faces, right? And if that's a square pyramid, then all 4 of those triangles are going to be congruent, right? So to find the surface area, you just have to find the area of the bottom, and then the area of all 4, or 4 times the area of one of those faces, right? Volume is a little different. This is not a prism, so it's not area of base times height, because that shape gets smaller the farther you go up. But there is a consistent scale factor, basically how small it gets every time, no matter what. Anyone know what that is?
2.
Do you know what it is?
Would it by chance be at 1/2 base times height?
Good guess. That's if you're finding the area of a 2-dimensional triangle.
Yeah, I assumed it.
So what if you're finding the volume of a 3-dimensional pyramid?
Did we learn this in math exam?
We
Isn't it
did.
like 1 or 9, 7. I can't.
4/3 pi r cubed. That's the volume of a sphere. But volume of a pyramid. So I just gave you a pretty big hint. To find the area of a 2-dimensional triangle, that's 1/2 base times height. So to find the volume of a 3-dimensional pyramid, it's 1/3 area of base times height. So it's not area of base times height. It's 1/3 of that. So area of base times height would be the pyramid, right? Or not the pyramid, but the prism. So area of base times height would be a prism that looks like this, right? That's the That's the prism because that same base, that same area is multiplied this many times because there's that many layers of cubes, of cubic units that you can stack on top of itself. But for a pyramid, that gets smaller. So technically, if I wanted to, I could ground this to dust and fit 3 of these inside of that prism that looks like that with that same height. Okay? Now you couldn't take the solid pyramid and fit 3 of them inside of that prism because it doesn't work that way. But if you ground it all in the dust, the volume's the same. The volume of a prism of the equal height that goes all the way up like that equals 3 times the volume of this pyramid of the same height. Okay? So this is 1/3 area of base times height. That's the volume. Okay. Now, and technically surface area is area of bottom or the base plus the 4 faces, right? Okay, so that's going to change depending on what kind of pyramid you have. Well, if I have a pentagonal pyramid, that didn't work. If I have a pentagonal pyramid, well, now there's 5 faces. So that little formula doesn't really work.
It's not really.
You're not really a pyramid. It is a pyramid. It is a pyramid. There's nothing that says you have to have a square bottom. That's kind of weird. Okay. You can have any base you want. You can have a hexagon. You can have a decagon, a dodecagon. You can have any kind of base you want as long as it comes up to 1 point. It's a pyramid. Yes.
It can be your face 4 and
Yeah, and faces, but there's an easier way. Okay. So here's the deal. The vertex of a pyramid is right here. This is what we call the vertex. Kind of makes sense because it's where all the faces come to a point. Okay. Vertex of a pyramid is the common vertex of the pyramid's lateral faces. So these are the lateral faces. We call it lateral faces because this bottom is called the base. So if that's the base, these are the sides. So lateral literally means sides. Okay? All right. So the base of the pyramid is the face of the pyramid that is opposite the vertex. Okay? So it's not, we don't say the bottom because it's not necessarily on the bottom. You could have hold a pyramid upside down and the base is no longer the bottom. It's the top. So basically we say the base is the face that's opposite the vertex. Okay? Opposite meaning look across, that's what you see. It's not touching the vertex, it's opposite of the vertex. Okay? A regular pyramid is a pyramid with a regular polygon as the base. So this is good to know. Regular pyramid. The only definition that you need to worry about is base is regular. So if this was a regular pentagon, this would be a regular pyramid. If this was actually a square, this would be a regular pyramid. If it was a rhombus that wasn't a square, then this is not a regular pyramid. It's got to be regular. All sides and all angles are the same. Okay?
I like your mug.
Thank you. Yeah. Mrs. Bynes got that for me. That's funny.
Is not important. I don't know when I'm going to use this in life.
Yeah. Well, when are you going to use importanter?
Probably most of the time, if I'm being honest.
Yeah. Only the important stuff.
You mean the important verse?
Okay. So now there is a height. You guys know the height is this guy right here. So the height, if I were to draw a line straight down, this would be the height. Okay? But there's another line. There's this line on the face. This is called, which is kind of perpendicular. It's perpendicular to that, but this is called the slant height. Okay, it makes sense because that's the height of that triangular face. Okay, and why do they say it's slant? Because it has to lean over a little bit to reach the point, right? So they call it the slant height, all right? And here's what they do. They call slant height lowercase l, which is an annoying variable because if you don't write it in cursive, it looks like a 1. Okay, so write lowercase l in cursive. Little loop-de-doo, all right? Okay, are we doing all right so far?
Yes.
Okay, so let's move on. Now, all this is going to lead us to something here. So the lateral area can be determined doing this. Watch this. The lateral area, L, equals 1/2 PL. What's P stand for? What's P usually stand for? Perimeter. So, and what's lowercase l?
No.
Slant height, okay? So if we know the slant height, which we need to know to find the area of that triangular face, we need to know that, right? How do you find the area of one of those triangles? Well, that's just one of those sides. One of those sides times the slant height divided by 2, right? But then you're going to multiply that by 4. So one of those sides times 4 is the perimeter. So now you're left with 1/2 perimeter times slant height. Now you could do it one at a time if you wanted to. Find the area of one of the faces and multiply it by however many sides, like n sides. That's fine. But n times sides is just perimeter. So just make it simple. The lateral area is just 1/2 PL. Okay, so this is 1/2 PL. So let's see if we can calculate the surface area, or maybe just the lateral surface area of this regular pentagonal prism. All right, I'm going to give you one of the sides, and I'm going to give you one of the slant, or just a slant height. Okay, so find the lateral area of this regular pentagonal prism. Got it? Who's got it? Who's got it? Justin?
Is it 30?
It's not 30. Find the perimeter. I think I know what you did. How do you find the perimeter of a regular pentagon? Well, how many sides is it?
It's 5.
Yeah.
Oh, how you find it is it's 2 centimeters, and there's 5 angles, and so 2 times 5 is 10.
Yep.
So half times 10. So half of 10 is 5,
Okay.
and then 5. Is it 10?
5 times 5.
5 times 5 is 25.
Yep, there it is. 1/2 10 times 5, right? Because the slant height is 5, and the perimeter is 10. So that's just half of 50, or half of 10 is 5 times 5 is another 25. And remember, our label is square because we're not finding the volume, we're finding the area, surface area, all the surfaces, okay? So this is just asking for the lateral area. Now, we did learn how to find the area of that base of a regular pentagon, but in this case, they're just wanting the lateral area. Okay, so here's how Saxon calls it. Instead of this confusingness, they say surface area equals B plus L. So capital B means area of base. Capital L means lateral area. So this is gonna be different every time, depending on the base, but this is always 1/2 PL. Okay?
What is that area of
Base.
okay, sorry.
Yeah, so Saxon likes to say, okay, capital B means area. I don't like that. I like to just write it out. So it's just area of base plus lateral area. All right. Okay, see if you can do this. Ready? I'm going to read it to you, and I want you to figure it out. You ready? Calculate the total surface area, not just the lateral area, but the total surface area of a regular hexagonal pyramid with a slant height of 12 centimeters and a base side of 3 centimeters long. Okay, let me repeat that. Hexagonal pyramid.
Can you draw it out?
Oh, yeah, I want you to draw it out. Okay, so I will give you the information again. I'll write it down. But I want you to draw it out. If it helps, you don't have to draw it out, but if it helps you, you can draw it out. Find the surface area of regular hexagonal pyramid. Okay, hexagonal pyramid. So slant height equals 12 centimeters. And the length of one of the sides, base side, one of the base sides is 3 centimeters. Okay, now if you get this first, I'm going to give you a free problem set. Okay, yes.
Wait, what was it?
I think I saw.
Okay, what do you got?
Say it out.
Yep.
Is it a 108?
Nope.
Wait, slant. 36.
Okay, so how do you do this? How do you find the total surface area of this shape?
Hexagon is 5. Right?
Wait, so that's. Is it 72?
No.
Okay, then I have to actually do 1/2.
Yeah, you might have to write this out. Start here. Total surface area.
Oh my god.
Okay, and you can round your answer. It's going to be a decimal, so you can round your answer to like the nearest 100. What do you got?
got 72.
This is definitely worth the free problem set because it's a tough one. You have to remember stuff.
Dang it. I don't like that's a hexagon.
I know. It makes it difficult to find the area of that base.
Because like
The lateral area is no problem, right? You can figure out the lateral area, but that area of the base, you got to remember something. How do you find that? How do you figure that out?
okay. Dang it.
This would be like if I didn't review for the test and this was on the test, it would be an extra credit problem. Because take some thinking.
What's that say? Latitude? What's the big L?
Lateral area. The lateral area is right up above it. That's how you
What's the P
calculate.
stand for?
What do you think?
Perimeter?
Yeah.
Can I like ask you if the base area of base is right? That one I have, because I have 54. Is that right for area of base?
No.
Okay. Because I know the only way I know how to find like area of base is to make it for hexagon is to make it into 6 little triangles. And I know isn't it 3 by 3? Oh, I have to divide it in half, so it'd be 27.
But it's a little bit more complicated than that because the height of each of those little triangles is different.
Ah.
So I'll draw it for you just so we have a nice drawing.
Yeah.
See, 3, 3, 3. Slant height is 12. Oh, yeah. So you could do this the old-fashioned way. Find the area of each of those sides, or you could just plug it into the lateral area. And then to find the area of that hexagon base, you could do it how Tori did it. Just break it up into 6 different triangles, Trivial Pursuit it. Do you have an answer, Tristan? So give it to me to the nearest hundredth if you have it. I'll give you a couple more minutes. Because it's a fun
So nearest 100th?
challenge, yeah.
I think I have it 134.65.
You're really close.
What did I mess up?
Okay. I'm a bit.
That was a calculator, by the way. I wasn't on my phone for anything else.
Oh, I didn't notice you on your phone.
You're just more sneaky about it than me.
Thank you for saying that, though.
Yeah.
If you were on your phone, I would find it difficult to be mad at you because you're Maddie. Do you struggle with that or no?
What?
Do you get mad at your sister?
Get mad at her?
Yeah.
Yeah.
I was gonna say it's siblings. You can't say you've never not gone mad at your sibling. They're horrible.
Yeah. So my older 2 kids,
I don't want to do this anymore.
I don't think I ever get mad at them. But my younger 2 kids, I get mad at them a lot. And I think it is with each other. I don't think the younger kids ever get mad at the older 2 siblings. Braden and Malia are just weird because they like are so, yeah, they just, what's the word? Agreeable. Like you just, like they never do anything to tick you off.
I get in a fight with each of my siblings at least like 30 times a day.
That's good. That's good and healthy. That's
Yeah,
good.
thank you. I agree.
Wait, how many kids do you have?
4.
Four. It's 2 and 2. 2 older, 2 younger.
Yeah.
Because I was listening. No, I'm joking. I'm joking.
All
I didn't
right.
hear how many kids you
I don't want to do this anymore.
Okay, don't do it.
Wait, if you give me a second, there's a chance I can get it.
Okay. How many seconds do you
I
need?
would like to.
72.
I need one more calculation, but I've got the number.
72 seconds.
When Maddie and I were younger. Ooh.
Yeah, when they were younger, they fought all the
I
time.
actually used to
Is
get
it
along better with my sister when we were younger.
165.53.
I forgot you had a sister.
Yeah, she's
No,
not
okay,
very
let's do this. You guys ready?
Tell me.
So I'm gonna start here. S equals B plus L.
That's what it
Okay, so how do you find the area of a regular hexagon?
says SA equals B plus L, not just S.
I know, but Saxon says S. But so how do you find the area of a regular hexagon? You guys know how to do that? Do you remember that? This is 1/2 AP. What's A stand for?
Oh, S.
Nice. Good one.
Oh well.
It doesn't stand for that. So it stands for apothem.
Yeah.
Not what you said.
I knew it wasn't area. So
Okay, well, how do you find it? What's the apothem? Well, let's draw a hexagon. This is the apothem, remember?
So
Yeah, that's what I couldn't figure out was the
So not 3. If
opposite.
this is 3,
and the angle would be 60.
I would have solved if I
so
known.
this
It's
is
gonna be
3
radical
halves.
3 and then 6.
So this is 3 radical 3 over 2.
I got this far.
So not 3 radical 3, but 3 radical 3
Oh my
over 2.
God.
I forgot about that.
Okay,
Oh.
so now you could find the area of one of these triangles. So base times height divided by 2. So that ends up being, what is it? 9 radical 3 over 4. Okay, but that's kind of confusing. Whatever. Let's just plug it into here. So 1/2. Oh, by the way, L is 1/2 PL. So this is 1/2 PL, lowercase l, right? Slant height. So we have all this information now. The only thing we needed to get was that apothem. So 1/2 times 3 radical 3 over 2 times the perimeter. What's the perimeter? 3 times 6 is 18, right? Plus 1/2 perimeter, 18, times the slant height, which is 12. Okay, so this guy is the only weird one. So that's 9 times, so 27 radical 3 over 2 is about 23.38. But this guy is just 9 times 12, which is 108. Add them up, it's 131.38-ish. So it's involved, right? It's a difficult problem, lots of details. But if you have these formulas in front of you, which you can when you take a test and when you do homework, then you have to figure that out. The hardest part is finding that stinking apothem. Okay? Tori hates the apothem.
I do too. So this is why I'm asking this question. On the test, on 13A or B, is there going to be like an apothem problem?
Well, we will just have to find out on Thursday.
I
But if there is one, I'll make sure that you guys are prepared and ready to go. All you have to do is do the math, okay? But here's the deal. The apothem in a hexagon is just this number divided by 2 times radical 3, because that's a 30-60 right triangle. So the apothem is going to be just multiplying by a radical 3 of half of that side. But we'll figure that out once we start reviewing for a test on Thursday. If there's something like that, then I'll make sure you guys are ready to go, okay? I don't know that there will be, but we'll see. Questions? Comments?
Right there now.
Oh, the last part is volume. Are you guys good with volume?
Yep.
It's just area of base times height divided by 3, or 1/3 area of base times height. So I'm not going to bore you with that.